So for our last example, this is now example 3. Example 3. Suppose x and y. Suppose x and y have a discrete distribution. With the joint probability function. Probability function given by f of x, y. This is defined as C absolute value of x plus y. C is a constant and the x is taking on values from -2, -1, 0, 1, 2. Then y is taking on values. Y is taking on values -2, -1, 0, 1, 2. Then the distribution is 0 otherwise, elsewhere it is 0. Part A, I want to determine, we want to find the following. Determine Roman 1, the value of C. Roman 2, the probability of x plus y greater than 2. Then probability Roman 3, this is probability of y less than a half, y less than a half. Then probability of x equals 1 and the probability of absolute difference of x minus y less or equal to 1. Yeah. So to determine the value of C, we do what we have defined, what we have went through for the previous example. So what is the key issue here for Roman 1? The key issue is to sum over all x values over all y values, f of x, y equals 1. That's what we are applying. Now, as I said earlier on, one can decide to summarize information in a table. I think for this case, now that for the other case I did not use a table, allow me for this case use a table. Yeah. Otherwise, one can also have the following. So x is -2, x is -2, -1, 0, 1, 2. Y is -2, -1, 0, 1, 2. Those are the possibilities which we are having. So still one can look at x is -2, then you vary the other values of y. X is -1, you vary all the other values. X is 0, you vary like that. Alternatively, we can summarize our information in a table as follows. So how we have x and then have x, and then there is also y. There's also y. X is taking on values -2, -1, 0, 1, 2, 3. 3 is not there, sorry. Those are the values of x. Then y, I think I should put this down. Otherwise, going to confuse myself. So x is -2, -1, 0, 1, 2. Then y is -2, -1, 0, 1, 2. Right. So this is our table. Okay, that. So meaning that now look at the value which is supposed to be here, the value which is supposed to be put there. That is the value which is supposed to be here. That is the value which should correspond to a bit of x equals -2, y equals -2, like that. Now the value which is supposed to be put there, that is the probability of x equals -2, y equals 2. So you see that this row, is it a row? Yeah, I think it is a row. This row here, that first row, captures the case where x is -2, then y is varied. Then the second row captures the case where x is -1, y is varied, and so on, so forth. Therefore, allow me feed in these values. How do we feed in our values? Like here, for the first entry, x is -2, y is -2. What is our distribution? Our distribution is C. Our distribution is C absolute x plus y. Absolute x plus y. So for that first entry, I have C. What is x? -2. What is y? -2. And that is the same as C -4. So absolute is just there to make a negative value become positive so that the answer becomes 4C. So here I have 4C. Then for the second entry, x is -2, so I'll have C absolute -2 plus -1, and this is C absolute -3, which is 3C. So this is 3C. Then for the next entry, x is -2, y is 0. So we shall have -2 plus 0 absolute. This will give us 2C. Then next, x is -2, y is 1. So -2 plus 1, we get -1 absolute, that is +1. So therefore that becomes C. Then x is -2, y is 2. If you add the 2, you get a 0. So this is a 0. Same thing here. I add as I take the absolute. I add as I take the absolute. Therefore, this will be 3C. This will be 2C. This will be a C. This will be a 0. This will be a C. Similarly, here we shall have a 2C, a C. This will be a 0. This will be C, 2C. This is C, 0. And this is C, 2C, 3C. This is 0, C, 2C, 3C, 4C. Right. So I sum all those possibilities and I equate to a 1. So what shall we have? We'll have the following. We have 4C, applying our property, 4C plus 3C plus 2C, 4C plus 3C plus 2C plus C plus 0. That is for the first row. 4C plus 3C plus 2C plus C. Second row, that is 3C plus 2C plus C plus 0 plus C. Third row, 2C plus C plus 0 plus C plus 2C. Third row. Fourth row, C plus 0 plus C, 2C plus 3C plus 0 plus C, 2C plus 3C plus 4C equate to a 1. Therefore, we sum. Now you see for the first row, if I sum 4C plus 3C plus 2C plus C, what is that? That is 7, 9, 10. So here I get a 10C. Then here, the next row, that is 5C. 3 plus 2, that is 5, plus 1, 6, plus 1, 7C. Then this will be 6C. Then this will be 5, 6, 7, 7C. And finally, this will be 10C. Like that. So 10 plus 7, that is 17, plus 6, that is 23, plus 7, that is 30, plus 10, that is 40. Therefore, here we have Here we have 40C equals a 1. 40C equals a 1. So this should imply that the value of C is 1 over 40. Like that. Then part 2, Roman 2 required us to evaluate the probability of X plus Y greater than 2. So we interpret this. So we want the case where the sum, is above 2. So recall that X was taking on values -2, -1, 0, 1, 2. Y was taking on values -2, -1, 0, 1, 2. So the case or the possibility for the sum to be greater than 2, so we keep on adding. For example, if I add -2 plus -2, that is -4. That is not above 2, so that is impossible. -1 and -1, that is -2. Still, it is not above 2. So you see how we treat this thing. Still, if I consider 0 and -2, 0 plus -2, I get -2, which is still not greater than 2. So we only look out for those possibilities where the sum can be above 2. And I want to say that that is possible if X is 1. If I pick X equals 1 and X equals 1 and Y equals 2. Because 1 plus 2, I get a 3. 1 plus 2, I get a 3, and that is above 2. So therefore, the first possibility is that probability of X is equal to 1, probability of Y x equals 1 and y equals 2. Yeah, because the sum of those two results in a 3 which is above 2. Then I explore another possibility. Another possibility, so look at the case where I have x equals 2 and y is a 1. That is probability of x, which is a 2, and y is a 1. Sum those two, you get a 3, and the 3 is above a 2. Therefore, that qualifies. Then also, I have the case where x is 2 and y is 2. So that is probability of x equals 2, y is 2. So if you add the 2, you get a 4, which is still above 2. So those are the only possibilities which I have. Therefore, I go to my table and I look out for these values. X is 1, y is 2. X is 1 and y is 2. X is 1. Look at the row for x equals 1. It is this row. X is 1, y is a 2 is here. X is 1, y is a 2 there. So we have 3c. So we have 3c. Then plus x is 2, y is 1. X is 2. Look at the row for x is 2. Look at the row for x is 2 and y is 1. Still it is a 3c. So plus c plus 3c. Then plus x is 2, y is 2. X is 2, y is 2. X is 2. The row for x is 2, y is 2. That is a 4c. So plus 4c, and this is equal to 10c. Therefore, this is 10 times the value of c, which was the, I think c was, what was the value of c? 1 over 40. 1 over 40. Therefore, this is a quarter. Is a quarter. Then for part 3, we want to determine the probability of y less than a half. Recall in our first example where we had a certain value of y which was fixed. So still here we look at the case where y is fixed. Because this is only considering the case where y is less than a half. Then x is kept on varied. So what is y? Observe that the values of y were -2, -1, 0, 1, 2. Those were the values of y. Those were the values of y. And now I'm interested in y less than a half. These were the values of y. I'm interested in y less than a half. So for y to be less than a half, look at 2. 2 is above a half. 1 is also above a half. But 0 is less than a half. -1 is less than a half. -2 is less than a half. So these are the cases where y is less than a half. So therefore, this is the probability of y equals -2 plus probability of y equals -1 plus probability of y equals 0. So we start with y equals 2. So y equals 2 simply means that y is fixed, then x is varied. Y is fixed. If you recall in my first example, y is fixed, x is varied. Therefore, for y is 2, that is the same thing. For y is -2, sorry. Y is -2, that is the same thing as saying probability of y equals -2, comma, x is what? X is -2. Anyway, I don't know. I think I should use this table because this is quite obvious. This is quite obvious. Anyway, before I use the table, let me first explain. X was -2, -1, 0, 1, 2. Now, if y is -2, y is fixed. So you look at y -2, x -2, y -2, x -1, y -2, x is 0, y -2, x is 1, y -2, x is 2. You do that same thing for y equals -1. For y equals -1, y -1 is fixed. Y is fixed, but x is varied. X is -2, -1, 0, 1, 2. So you look at y -2, x -1, y -2. Sorry, y -1, y -1, x is -2, y -1, x -1, y -1, x is 0, y -1, y x is 1, y -1, x 2, like that. So now that this is very obvious and I have my table there up, allow me just apply my table. So y -2, y -2,